All right, in this video, we're going to be talking about proportionality. And with this, we are going to talk about what it means if something is directly proportional or inversely proportional. All right, so if it's directly proportional, then we'd have a statement that says like y varies directly as x, and that's going to translate to y equals k times x. Now this k is the constant of variation in this formula. And when it's saying it's varying directly, it means that that constant of variation and x are going to be multiplied together. Where when we talk about inversely proportional, right, we can see that the formula now is connected by division instead, right? We've got y equals k divided by x. So again, we have that constant of variation. When it says it's varies inversely, then that's going to mean divided by x instead. Okay, but on a problem like this one, the loudness L of a sound measured in decibels is inversely proportional to the square, right? So let's make sure we remember, we see that part there, the square of the distance d from the source of the sound. So this first equation that we're going to have here, or the first part that we have, is going to be made into an equation, but we want to kind of translate it into equation form before we start putting our numbers in, because this is a little bit different since it says that it is inversely proportional to the square. So if I was to write this down, right, then I'd have L is inversely proportional, so that means I know it's going to be connected by division here, right? So I have K on the top and then the square on the bottom. So it's not just X like we have here, but we're going to be having, since we're talking about the sound, we'd have D squared, right? Instead of just the D on this. And then we're going to go ahead and put in our numbers that they give us here. All right, so remember, so 7, a person is 7 feet away from a jet ski. It's 30 and it's 80 decibels loud. So in place of our L, we'll put 80. All right, we don't know what K is. That's what we've got to solve for first. But D is the distance away from the jet ski, and so that's 7 feet, but it's not just 7 on the bottom, it's 7 squared. All right, so then when I rewrite this down again, let's simplify this up. We get 80 equals K over 49. And then to solve for K here, right, K and 49 are connected by division, so I need to multiply both sides by 49. All right, so my 49s divide out there, and then here I'm left with K equals 80 times 49 is going to give me 3,920. All right, now I'm not done yet. That just tells me the constant of variation, because that's not even where my question is, right? My question is down here. How loud is the jet ski when the person is 50 feet away? All right, so let's go back to the original equation that we made there, right? The L equals K divided by D squared. And this time we're trying to figure out how loud it is. And so we've got L is what we're trying to find. In place of K, we'll put our constant of variation that we found, 3,920. And then this time our distance is 50 feet away. And so we'll have 50 squared on the bottom. All right, but then let's simplify this up. And 50 squared is really 2,500. And then if I divide these two numbers, so 3,920 divided by 2,500, that's going to give me 1.568 decibels. All right, and then make sure you notice if it asks you to round to a certain place value on that. But otherwise, if it doesn't, then that would be your answer. That's how loud that jet ski is for you if you're 50 feet away. All right, so not loud at all compared to if you're only 7 feet away. All right, I hope that was helpful.